Everyone, my name is Sam Duffield and I'm the chair of the Devon and Cornwall Young Professionals Network. Joining me tonight, as you should be able to see, is Jake Shaw-Sutton from the University of Plymouth. Jake is a senior technician and the original creator of Combat Bots, so he'll be here to answer some of your more technical questions and anything that I can't answer. Hopefully he'll be able to show us a few things as well throughout the webinar. So this competition is designed to both welcome newcomers into the field of robotics while challenging experienced coders and makers by putting their designs against equally skilled competitors. Tonight's presentation is relaxed and informal. We're welcoming makers, coders, engineers and scientists from all abilities and all regions of Devon and Cornwall. All the way from secondary school level to seasoned principal engineers that I can see in the attendee audience as well. If you have any questions, please feel free to put them in the Q&A box, which should be down below, and we'll answer them at the end. So without any further ado, let's get started. So what is this all about? What's this whole Combat Bots thing that you would have seen emails and newsletters and Facebook posts about? Some of you in the audience may be old enough to remember BBC's prominent primetime TV series, Robot Wars. So Robot Wars was aired on BBC Two between 1998 to 2001 and was briefly revived from 2016 to 2018. It has since spawned thousands of spin-off competitions that mirror the same principle. So you've got BattleBots in North America, which started in the year 2000. You've got the first League of Robotics, which soon followed after that. You've got hackathons and technology conferences that followed in the rise of the Silicon Valley enterprises and the dot-com bubble burst. But for me as an engineer growing up in the UK, Robot Wars always felt like the first of these competitions. And I'm sure some of you older engineers might say, well, competitions like the Great Egg Race or Scrap Heap Challenge may have come before that. But Robot Wars seemed to be the core and one of the first. It's one of my favorite TV shows to watch on a Friday night. You can combine the visceral destruction of animated machines with the lively commentary of Craig Charles, and it made for great viewing as well. And it made engineering, science, and technology fun as well. However, unless you had in that time period a welding machine and a steel cutter at home, and few of us do, the barrier to entry to entering the original Robot Wars competition was quite high. So not every family had access to high voltage benchtop power supply equipment, nor did they want to test brushed DC motors, which could potentially have stator voltages in excess of 100 volts, which isn't really safe in your domestic home. However, as time has gone by and technology has evolved, we can recreate the same competition on a smaller scale because technology over the last 20 years has shrunk to allow us to do that. So we now have small micro gear motors, LiPo batteries, 8 and 32-bit microcontrollers, RF receivers as well that now cost, in some cases, mere pennies or integer pounds. 3D printing as well has seen a huge rise in the domestic marketplace as well. I'm willing to bet most of the students that are attending tonight have got 3D printers at home. The University of Plymouth has a huge bank of printers. Some of you that have joined tonight from companies likely have a 3D printer at work. So we've seen a huge surge of additive manufacturing as well that doesn't require huge sheet steel cutters and welders that the original series required. So all of these factors mean that we can recreate that special competition from the 90s and the year 2000s in our own homes, and we can do it on a smaller scale in Devon and Cornwall as well. The competition is truly open to anyone. Truly open to anyone from all abilities. And the whole point of the competition is to inspire a community feel as well. So towards the end of the call, I'll be sharing a link with you for our Discord community where you can share your design and build. By all means, take photographs, videos of your progress, ask questions so that the community can respond, or myself and Jake may be able to give some tips. And we all as a Devon and Cornwall community can hone our skills in the robotics and autonomous, or what they call the RAS space that seems to be bubbling at the moment. So without further ado, I'm going to show you a short video that Jake, who's on the call, put together in 2019 of the Combat Bots final that was hosted at Plymouth University, so that you can see the type of events that hopefully you'll be entering into the final over the next year. So I'm hoping this works.
Two, one, activate.
Don't take the arena again. Oh no.
Three, two, one, activate. And the winner of the first Combat Bots tournament is Rango.
Brilliant. I remember that. I think that was at one of the open days that we had at Plymouth University. And I think of all the stands that were there at that event, wasn't that in the Sherwell Centre? I think it was, Jake.
Yes, it was just up from the staircase on there, right on the balcony, and there are announcements and all sorts going on, but we always had a rather packed area around there,
Yeah.
which it's fun to think back, especially in the times we're in at the moment, but it was packed, it was silly, and everyone was just enjoying it.
No, and it was brilliant because you had, I think you had PhD students showing some quite technical subjects with their posters and everything. And I remember some of those PhD students abandoning their posts with their posters to come and come and witness the final of the competition as well. So no, brilliant stuff, really good stuff. So what is then, so if you want to get involved and you like the look of what we're planning and you want to get involved in the competition, what does the timeline look like? So we're today, well, where we are now in April 2021, we're publishing the rules and joining instructions for everybody to get involved. So you may have seen that through the Devon and Cornwall IET newsletter, any university internal channels, college internal channels, or you may have seen PDFs flying around through your local employer as well. So we're rolling everything out at the moment in terms of rules and joining instructions. Then in May, we're looking at doing another Zoom call like this, where we can actually start having discussions and collaborating on robots. So we'll actually start going into more detail about what type of microcontroller you might want to select, what type of transceiver you might want to use, how you may want to get started with 3D modeling and 3D printing, what sort of design that you want to pick for your main weapon. And we'll start doing all of that towards the end of May. Then through the summer months, a lot of the students go back to home, or they may stay through the summer to work through a summer placement. That'll be time for both students, staff, local engineers, scientists, secondary school students to really plan, design, and experiment with what they're going to build, kind of like a summer project. And if you have any technical queries or you'd like any further information while you're working through that over the summer, that's when you hit the Discord server and you post a question. You can take a photograph or a screenshot and say, hey, I'm struggling with chamfering an edge in Fusion. How do I do that? Or how do I rotate a model in Fusion to be able to cut through? Or what type of motor should I use with gearing? All of those things as a community, we can all help you answer and better our understanding collectively. And then in August, we'll have another Zoom call where we'll have a bit of a show and tell session. So people will be able to, if they haven't already built their ideas or prototyped it or mocked it up virtually, they'll be able to show what they've done and see what other people have done and kind of compare ideas. And really then from September to December, we're hoping as students return to university, apprentices return to college, students return to school, and as we as engineers and scientists in our place of work, once the kids go back to school and we get back into the routine with working on normal hours and not taking time off, that will really give us all time then to knuckle down, build, print, solder, assemble and test. I know for a fact I'm probably going to be stealing the benchtop equipment at work during my lunch break to assemble my stuff. Students will get the chance to do the same at their university, secondary school students at their sixth form college, etc. And then I'm hoping in December, fingers crossed, COVID allowing, we'll have our first physical event kind of around Christmas time then, just before everybody breaks up, and that'll kind of be like a preliminary round or like a build cafe, a networking opportunity for us all to get together for the first time and see what we've all come up with and share ideas and kind of test things. And then February next year, that's when we'd look to have our first physical event and regional finals. So that's where you kind of get to test your robot to the extreme and pit it against each other. Beyond February, and Lydia on the call may want to back this up, but beyond February, University, I know they don't belong to Devon and Cornwall, have thrown down the gauntlet for a bigger Robot Wars event on a bigger scale. So this combat bots competition may be an opportunity for you to hone your skills on a smaller scale before your local university or college on campus network wants to put together a bigger robot, a heavier weight class to compete against Leeds University and the rest of the nation, the rest of the UK on a much bigger scale. So there'll be more details of that come out closer to the time. I know that was meant to be scheduled for 2021, so that will roll forward into 2022. So quick start rules then, if that's the timeline, how can you get started building right now if you've got a 3D printer on your desk and you're raring to go and you've got your Arduino or your STM32, where do you start? So the quick start rules are your robot must fit within a 4-inch cube, it must not weigh any more than 150 grams, and it must have a safety cutout switch. There must be a way of powering it down. The weapon types that are on the right there are not permitted. So obviously we don't allow any explosive weapons, rotating weapons that may shatter, inductive systems, glue, string. Jake, is there anything in particular that students have asked over the years that you've definitely gone, no, we're not doing that?
I'd probably say the most popular, controversial, shall we say, option is always Tesla coils, high voltage, or some form of RF interference, which is, okay, when you're looking at two effectively remote controlled robots and you're trying to beat the other one, yes, you could stand in front of the other person, block their view and stop it. But at the same time, that's not really competing. So the understanding around that is pretty general. In terms of the designs and what works best, there's a lot of variety and there is no one solution. Often it's more a case of rock, paper, scissors. One can beat one type, but that will also be beaten by a different type, but that would win against that one. So you just got to design around and try and think up all the solutions in that.
Yeah, so we're looking for fair competition, really. By all means, if you come up with a novel weapon system that fits within the rules and it totally works, fits within the rules, totally works, and you end up destroying your opponents in the arena, that is fair game. But what isn't quite fair game is if you somehow manage to work out a way of blocking the entire 433 megahertz bandwidth of frequencies or the 2.4 gigahertz. That, you know, we class that down the bottom there as electronic warfare, and that's not really in the interest of the community. We're looking for physical solutions rather than EW solutions. So if you want to get started now and you are totally new to electronics and you've got no idea what parts that you need or even how to draw a circuit or put together a circuit schematic, that's fine. Again, the whole point of the competition is to level up everybody's skills, no matter where you are on the spectrum in terms of your engineering ability. So in the PDF pack, which I'm going to put a link in the chat to in a minute, you will find links to recommended parts that you may want to start with. These are generally good quick start parts. And I think, Jake, you've put together a bespoke PCB that entrants might be able to order.
Yeah, and more details of that will come in the near future. But the whole idea of the combat bots and making these robots is to make the barrier to entry for these basically as low as possible and make it as easy and also as customizable and as fun. There's no point spending a fortune on a tiny little thing which is meant to get damaged or destroyed. So something that will be released soon in the future. I've got a photo of it just there, which I'm calling the Ant Core. So it's the main brain for one of these. It can accept up to 16 channels, can control it's got 4 motor drivers on board, an IMU, so an inertial measurement unit. So if it gets knocked around the arena, say, or it flips upside down, your controls will automatically invert, so you can continue around unhindered by that. And the whole idea, yeah, bring down the cost and increase the accessibility of that. More details of that will come in the near future.
Brilliant. And it's competitions like these that allow engineers to come up with cool, geeky, innovative solutions that Jake has just put there. And it really lets you stretch your legs. So of course, if you're a beginner, you can start with Jake's Ant Core board and then build your knowledge incrementally. But if you're more experienced and you're a senior engineer or principal engineer in embedded systems, you can really challenge yourself to see if you can make a device that's smaller than Jake's or quicker than Jake's, a higher clock speed, or has more channels. And as a community, we'd be really interested in seeing those. And I'm sure there'll be prizes at the final, not just for those who have the best robot that beat others. I'm sure there'll be prizes as we work them out as an IET committee for most innovative solutions in the electronic space, in the robotic space, in the 3D design space. The more cool the idea, the better, in my opinion. It doesn't just have to win the competition. So those were all electronics parts on the previous slide. So what about the actual hardware, the things that will actually do the damage? So you've got a couple of options here. You can 3D print. Well, in my opinion, there's three options. You can either 3D print a chassis. A lot of employers, a lot of schools, technical colleges and universities have 3D printers on site. And I'm sure if you work for a local employer and they have 3D printers on site, if you speak with a technician nicely, sometimes they'll let you print your own personal domestic things on the back reel of PLA that's kind of just sitting in the back of the lab, not being used. So 3D printing a design seems to be a fan favorite at the moment. You don't have to do that. You can use folded sheet metal as well. So if you're kind of old school and you really want to make it rugged, I know that when I was in secondary school, I made a lot of stuff out of folded sheet steel. You can go down that route as well. And if you're a dab hand with a lathe, you might want to lathe and turn pieces of your robot as well. So you can go down that. And then the third option is to be totally novel and completely hand make it from scratch, which would be quite an achievement, but at the same time would be quite a good demonstration of your hand skills if that is something that you're proud of and something that you want to showcase at the final. Personally though, if I spent hours and hours building something by hand, I wouldn't want to put it in the arena with Jake's robot because it would absolutely tear it apart.
One of my favorite examples of the robots in the video that you played at the start is one called the Ghost of Chow Mein. And the reason for that was it was made of a Chinese takeaway chicken chow mein container. It was literally just the old takeaway container, cut it in half so it was a bit smaller, and they put some wheels on there. Unfortunately, it ended up down the pit, and the main reason for that, the wheels weren't straight. They were very wonky wheels, so it kind of limped around. But it just goes to show, you can make these things out of anything.
Definitely. And I think that, again, the whole point of the competition is robotics as an application for everything as well. Not sure how far you could stretch that to pot noodle containers. We'll have to see if we can make a robot like that for the Leeds University national competition, a giant pot noodle container with wheels.
I mean, there's a wok would be a rather easy one because that's a nice hard shell, but going sillier, I like the idea.
Yeah, brilliant. Right, let's move on in the interest of time. So the University of Plymouth, who have hosted this event for a number of years now, have their own bespoke target arena. Now, if you're not an independent entrant, so if you're a student at a secondary school college, an apprentice at a technical college, or a student at a different university in Devon and Cornwall, we highly recommend constructing your own arena. Jake, have you got anything you want to say about the arena design?
So the original arena, the main floor of it, we just went with MDF, 2 layers of MDF. We had the top show layer, which was basically a floor that could be damaged, that has all the nice decorations on it, and then a reinforced bottom layer under that. The walls of it as well, instead of being a single layer, I went with double shock mounted polycarbonate. And the main reason for that, these little robots, which I'll show you more of these at the end of this, if you've got something spinning and something gets hit or something gets damaged, that could come flying away. So you want to make sure whatever does get hit or damaged stays within the box. And yeah, the key thing from it is it's a safe space that you can see inside. The original arena and the entire Combat Box competition started up. I think the total cost to build the arena, create some boards, create a few robots, and then to pitch the idea to management and initially at the university cost £100 from scratch. So it doesn't cost that much to build all of this, and if you can find parts, or if you've got, say, aluminium extrusion already laying around, you could make it for even less. So
no, that's a really good point. And I'm hoping on the next slide I've timed this quite rightly. Yes, that is a really good point. So if you are an academic member of staff at your university college, or you're a senior member of staff at your local employer, say you work for Babcock, Collins Aerospace, BAE, Bombardier, and you're thinking, how can I get funding from this? So if you work for a local employer, I highly recommend talking to your management team for the company that you work for. Stress that the event is funded, or the event is hosted by the IET, and it's a networking opportunity to get involved in STEM with students and apprentices at your local university and college. For something as low cost as £100 for an arena and pounds and pence for microcontrollers and 3D printing PLA, I'm convinced they'll stump the money up for that. If you are an academic member of staff at a secondary school, a technical college, or a university, and you're thinking, oh, where am I going to get the money from this, particularly if the education budget is quite tight, this would be a really good time for me to do a plug of the IET on-campus scheme. So at the moment, the University of Plymouth has signed up to this. They have an IET on-campus committee, and I can see some of them are attending tonight. That committee at the University of Plymouth, which is student-led, have access to up to £500 per event that they run. So they found, particularly for that £500, if the arena in terms of cost for materials is £100, they've then got £400 left over to help fund students' parts and materials to get up and running. So if you are a member of staff at a school or a college or a university that is not yet got an on-campus committee, I highly recommend following the link below that I've put down there, or take a photo of the QR code. I'll just pull the link up at the end of the presentation so that you can access it, and really stress to your students that there's kind of free money up for grabs here, and that the IET are willing to fund the students' participation in this event as well. So the barrier to entry really does drop even further, and in that anyone can almost enter, depending on, regardless of what their background is. So you can see there kind of the structure that we as a young professional network in Devon and Cornwall are running at the moment. So you've got the Young Professionals Network Committee, which I chair, and we meet once a month. And underneath that, we have got the universities, the technical colleges, and the local employers there. So you've got the big three: Plymouth, Exeter, and Falmouth University. The technical colleges that I have made contact with and are interested in getting involved are City College Plymouth, Cornwall College, Exeter, and Petrock. If your college or university or secondary school are not listed there, please get in touch and ask me about on campus, and I'll be delighted to send you some information, and we'll get you all set up to get access to that funding and get a committee going as well. So what do I do now is kind of the last question. Jake and I have kind of been rambling on for the last 20 minutes, half an hour, about all the pros of the event and all the benefits of getting involved. So what can you do right now to get involved? So there's a QR code and a link there that I've put in the chat with the informational PDF. Please download that, email it to yourself, to your work email address or your university or college email address, and share it around your colleagues, your students, staff, and ask them if they're interested in getting involved and signing up. The other thing that you can do as well is, again, you can scan the QR code or click on the link, is to join our Discord server as well. And that kind of acts as a community hub where you will see both committee members, entrants, and people outside of your employer or university bubble taking photographs and sharing pictures of what they've built and asking technical questions as well. And then the last step down there is to kind of get started and get building. So yeah, I think that's it. That's all I had scheduled to present. Jake, did you have anything that you wanted to show before I move on to the questions that we've had?
Yeah, you can do. I'll be able to show them on my video feed. So
brilliant. Well, I'll stop sharing. So I think your video should be bigger then.
Okay, so everyone should be able to see. One thing that is a bit difficult to really grasp, especially when you see these things on film and on video, is how big are these things? And just to show that, I've got a couple of them in front of me that I can raise up. The first one is the first robot that you see in the video, 240. Its latest version of it, shall I say. So the original one from that video, from that first competition, did get destroyed. As you can see during the fight, it dug into the ground, it started digging up the arena, and then it launched itself away and split itself in half. Bit unfortunate, but there was definitely room for improvement. So here is the robot as a whole, and as you can see, it basically fits in my hand. 4-inch cube for the overall size is quite small, and the weight of it, 150 grams. These things are diddy. They weigh basically nothing. Your phone, most phones weigh more than these robots do. But at the same time, the disc on this, you can see it's got a counterweight on there just to ensure it's balanced. The energy that this produces is equivalent to myself in a high heel jumping off of a 4-foot step ladder. That's how much energy is in the tip of this spinning blade when it's at max speed. It's a huge amount, which for something which is 150 grams, when it makes contact, well, things start going crazy and start jumping around everywhere. And that's part of the fun, because what's going to happen? With this weight, you're probably going to knock yourself away as much as the opponent. So that's the 240. And I've also got here a slightly more defensive. So to speak, that one is all about the weapon on the robot, using a little brushless motor from a drone and go all out against the opponents. This one is more defensive. So instead, the metal that it's made from, this was all done by hand as well. The metal, rather than needing a plasma cutter or anything fancy, it was done with a set of tin snips just for ease, and is made out of titanium, because you can get 1 millimeter thick titanium sheet for about 10 quid for like a square, a 10 to 20 centimeter square of it. The body of it is made of rubber, so a 3D printed rubber filament. So instead of it being hard, when it takes an impact, the whole thing is able to deform. And it's got a forward-facing flipper on that, which is actuated by a little servo down the bottom. And that flipper can go from fully closed to fully open in 0.16 of a second, which is quite quick. And it has the equivalent of 6 kilogram per centimeter actuating behind it. So it can lift a couple of kilo. So for something that's 150 grams that can move that quickly and throw it away, well, it can hop about. And yeah, the ultimate goal of these is they're accessible. You don't need a 3D printer. You don't need a huge knowledge of these things. It's, if you can think of a design, if you can think, okay, I want a little robot that's got an arm that can grab them, I can almost guarantee you can make those now. And you can make them for a low cost as well. Previous ones would have cost thousands of pounds. The original Robot Wars series, there are a few robots that were made for under £1,000, but the rest of them were in excess of it. Nowadays, this 240 robot, all in, cost £24. This one with the little flipper and the titanium shield all around it costs 16 quid to build from scratch. £16. And you can fight these against other robots. And
yeah, and the skills that you're using to develop these robots are exactly the same as if they were the £1,000 heavyweight equivalent. The electronics and robotics skills anyway. So yeah, it's the same skill set that you'll be learning that you'll be able to take back to your employer if you're a young professional, or if you're still a student, that you'll be able to show at interview when you go to your employer. So just to close off then, I've got a few questions in the Q&A box that I'm going to answer. So a couple of the questions are, will there be a recording available? Yes, there will. This is being recorded at the moment. And in the next week or so, it will be uploaded to YouTube on the Devon and Cornwall YouTube channel, where I'll then circulate a link to that so that you can view it back or share it around. Another question here, is this the same as Plymouth University's Robot Socks 150 grand combat bots event? Yes, it is. It is the same event, except this time it's the whole of Devon and Cornwall. So you won't just be competing against university and college students. You may be up against somebody who works for Atkins, who works for Babcock, and works for Collins. And don't let that put you off, because that's an excellent networking opportunity where you can talk to them about their graduate opportunities or their apprentice opportunities as well. Another question here, can you provide the link for downloading the PDF file of the quick start rules? Yes, I can. It's in the chat. Another question here, what happens if you're doing a master's in Leeds? So if you're going to Leeds University to do a master's, best of luck, because I think Plymouth are going to be thundering down, breathing down your neck quite quickly, kind of in revenge. So yeah, be careful with that one, because Plymouth University might come back to haunt you. We've got another question here. Will you get access to the recording? Yes, that's in the chat. So
one thing that's popping up is the links aren't in the chat. So I think that was sent to the panelists.
Ah, right, my mistake. Let me copy and paste that and do that again, but to everybody. Sorry, that's my mistake. All panelists and attendees.
And one thing that just stood out as well from your answer to the one of the previous questions, when you've got people from employers and big companies competing in this event, where if we've got also students competing in this, how great would it be for a student to beat whatever employer that they're wanting to then join? That's like a perfect proof of, well, I could beat your design, so.
Oh, exactly. And what a great thing to bring up in interview as well. When they start assessing your technical competency, you can say, well, what about your technical competency? Right. And then IET combat bots, sorry, IET on campus joining or startup information is available there as well. So that should be all the links. If for whatever you can access any of those links, there'll be another newsletter coming out, the Devon and Cornwall monthly newsletter, where all the links will be on there. So you'll be able to keep in touch. If nobody has got any other questions, I think we'll close it there. So Jake, I'd just like to thank Jake for attending tonight. This competition was Jake's idea back in 2019, and it's great to be able to roll it out across Devon and Cornwall.
And hopefully, well, I'm going to see a lot of people also excited to get involved in it. And thank you as well, Sam, for inviting me along to this and expanded the potential. Because, well, it's a good bit of fun. The more people you get into it, well, the crazier, the sillier, and the more fun you can have as a result from it. So this will be good.
Wait. Yeah, can't wait. Okay, I think that concludes the webinar, and we'll be in touch. So thank you very much. Thank you. Bye.